Bring on the air sickness bags and light up the fasten seatbelt sign. A new study finds that flights are going to become more turbulent due to climate change. Paul Williams led the study. It's been published in the journal Nature Climate Change, and he joins me now from Vienna. Welcome to the program.
Hi, Melissa. It's a pleasure to be here.
Your study finds that by 2050, we might see the frequency of turbulence on flights across the Atlantic doubling and also getting stronger. This has to do with the jet stream. Can you explain why?
Well, climate change is accelerating the jet stream, making the wind speeds faster. And this is making the atmosphere more susceptible to the particular instability that causes clear air turbulence to break out.
Clear air turbulence. In other words, not turbulence caused by a storm, right? And is
Right.
that more dangerous because of what pilots can detect on their radar?
That's exactly right. We all know that if a plane flies through a cloud or a thunderstorm, that is a pretty bumpy experience, but that's not the kind of turbulence we've looked at here. We're talking about the kind of turbulence you experience when you're flying above the clouds and above storms. You could literally say it comes out of the blue. You're flying through clear blue skies. Maybe the seatbelt sign is switched off and people are wondering about the plane. The conditions seem to be smooth, and all of a sudden you can hit turbulence unexpectedly that the pilot could not see from the cockpit window. And the fancy electronics on board the plane can also not detect this kind of turbulence. So it's particularly dangerous to air passengers. It's not just about drinks being knocked over. It is actually a serious problem that does injure many people.
Now, because we're talking about the jet stream, does this only affect flights going across the Atlantic?
So far, we've only crunched the numbers over the North Atlantic sector, but the jet stream, in fact, does not stop in the Atlantic sector. It goes all the way around the world and comes back on itself, forming a closed loop. And it is becoming more intense everywhere. So it would be a reasonable hypothesis to suggest that the sort of increases we're seeing in the Atlantic sector may also be seen in the Pacific sector and in other parts of airspace, but we haven't crunched the numbers yet. That's what we really want to do next.
Well, do you figure that airlines will have to reconfigure their flight patterns? Will have to change how they fly, where they fly?
Well, a pilot taking off from perhaps New York in the middle of this century to come across the Atlantic to somewhere in Europe will be looking at twice as much airspace containing turbulence. Now, they're going to face a choice that they could just grit their teeth and decide to fly right through those extra patches of turbulence. Or if the turbulence is particularly strong, they might instead decide to try to fly around it or above it or below it. All of this, of course, means that journey times could lengthen if flight paths have to become more wiggly and less of a straight line. This is an increase in journey times, maybe more delays at airports, and also, perhaps more importantly, an increase in fuel consumption. And I should mention that fuel is the number one cost to airlines. So any increase in fuel consumption will, of course, imply increased costs to the airlines. And ultimately, of course, it could be passengers who see the ticket prices going up to pay for that.
Well, the irony there, too, I suppose, would be that if you're increasing fuel consumption, you're also increasing the contribution to global warming, which will be causing the turbulence in the first place, right?
Right, there's a sort of feedback there, and it's a bit like poetic justice that maybe the atmosphere is somehow seeking its revenge on planes for causing this problem in the first place.
I've been talking with Paul Williams. He's an atmospheric scientist at the University of Reading. Thanks so much for talking to us.
Thanks, Melissa.